4,500,000,000 years ago, a solar nebula takes form. It is a cloud of stardust, the stellar nursery, the mother of suns. At the cloud's center, gravity pulls in huge amounts of gas and dust, making the center hotter and denser. The nebula is on the verge of becoming the hydrogen fusion furnace we call a star. Away from the seething center, other forms mimic the giant cloud, taking on the size and shape of planets. Upon ignition, the young star casts out a continuous spray of fast-moving particles called the solar wind. Nearest its source, this gale strips away any gas or dust not tightly locked within the gravity of the forming protoplanets. The star's blast sweeps away what little atmosphere the closest planet has acquired. The next three, though small, manage to hang on to small envelopes of gas. The gases lost to the forming spheres that would one day become the inner planets flow outward towards other swirling masses. With its belly full of fuel, the new sun burns with great intensity, settling into its nuclear balance. The solar gale calms to a gentler wind. Further out from the sun, distance weakens the power of this solar wind. Particles move more slowly and are easily captured by the gravities of the large protoplanets. The first of these coalescing outer globes, a giant in the making, carries off most of these particles. Three other giants, huge compared to the inner planets but still dwarfed by the king, will catch the rest. The four huge protoplanets sweep out the space they travel through, hurting and consuming all dust and small bodies in their way. A new solar system is born. It is the future home of life forms who will someday gaze into the heavens from their small blue planet, third from the sun. The huge gas giants of the outer solar system will draw their attention, and they will wonder. They will wonder at the nature of these outer planets, planets that have both the hottest and coldest temperatures of the solar system, planets so gigantic that they could easily swallow the Earth. These are worlds where fire and ice live side by side, the residents of an ice-cold and burning hell. As we journey outward from the sun, we encounter all the various kinds of worlds that our solar system has to offer. Of these, the inner planets, Mercury, Venus, Earth, and Mars, are made up principally of rock with small atmospheres. We then pass the asteroid belt, which may be the remnant of a 10th planet that once circled the sun, but which now only serves as the demarcation line between the inner and outer planets of our solar system. Like the inner worlds, the outer planets have mythological names. Jupiter carries the name of the king of the Roman gods. Saturn takes its name from the god of time. Urania, a legendary astronomer, supplies the name of the planet Uranus. The sea god gives the planet Neptune its name, and the god of the underworld supplies the name Pluto. We'll return to the Practical Guide to the Universe on the Learning Channel. We now return to the Practical Guide to the Universe on the Learning Channel. We can look at Jupiter in two ways, as a grand planet or as a pitiful stellar failure. When we say that Jupiter is a large planet, we are making an incredible understatement. Jupiter is absolutely enormous, by far the biggest planet of the solar system. It contains more mass than all of the other 8 planets combined.
Some people believe, based on a lot of data from Voyager and hopefully soon from Galileo, that Jupiter was almost a failed second sun, that we were almost a binary system, because Jupiter itself has a series of satellites, many planets, which are organized like our solar system. They're organized as a function of heaviness or density, so that the more dense and heavy satellites of Jupiter in that system are nearest Jupiter, and then they go out progressively.
Though huge, Jupiter rotates rapidly. Its day lasts only about 10 hours. This quick spin may cause its violent atmospheric patterns. Dense clouds cover the planet just like Venus, but unlike Venus, Jupiter's clouds divide into beautiful and ever-changing bands of colors. Movements of particular clouds seem random and chaotic, but on the large scale, they produce features that persist for years, even centuries. The best known and most dramatic of these features is the Great Red Spot. The red spot is essentially a very large weather system like a hurricane or a typhoon, but with three significant differences. This storm has lasted at least 300 years. It's larger than the entire planet Earth, and its winds travel at 800 miles per hour. That's faster than the speed of sound. Such unearthly pressure and constant turbulence in the air make manned expeditions below the clouds impossibly hazardous. But it is doubtful we'll ever venture near these clouds anyway. You see, Jupiter gives off more intense radiation than anything we've ever encountered on Earth. Jupiter's vast magnetic field acts like a particle accelerator so effectively that it produces almost 1 million rads of radiation. All the probes sent to Jupiter are devices made up of metal and inorganic compounds, so they can be designed to withstand this. However, we humans are a different story. It only takes 400 rads to kill a human being, instantly. Not a very bright picture for human exploration of the solar system's largest piece of real estate. From a human perspective, Jupiter, the planet, is much less important than the moons it possesses. It has at least 16 known satellites. Probably dozens more await discovery. Some of these moons are bigger than some of the planets and provide us with many possibilities. If life outside the Earth is to be found in the solar system, the moons of Jupiter offer the most likely place. Europa fascinates us most because water covers its entire surface. Frozen water, yes, but water all the same. Its icy surface is as smooth as a billiard ball and crisscrossed by thousands of huge dark lines. It has been theorized that the marks in the surface of Europa are really cracks in the ice caused by the upwelling of liquid water below the surface, much the same as is observed in the polar ice caps on Earth. So we suspect that sufficient warmth must be present on Europa at lower depths to sustain the kind of life forms that we have in our own oceans. With water, there is an improved possibility of developing habitable cities on the surface. Io, the third largest moon of Jupiter, is one of the reddest objects in the solar system thanks to its incredible volcanoes. Covered from pole to pole with huge volcanic eruptions, Io is clearly the most geologically active spot in the solar system. Jupiter's monster magnetic field plays havoc with Io, keeping its volcanoes erupting and its surface quaking. Like a cup of water boiling in a microwave, you can't see where the energy comes from, but the water boils all the same. Io shows the effects of invisible forces at work. Ganymede is the largest of Jupiter's moons. At 3,275 miles in diameter, it is bigger than the planets Mercury and Pluto. Callisto, the second largest of the Jovian moons, is composed primarily of rock and water ice. Galileo discovered these large moons with a telescope that he had built for himself for observation of the heavens, so in his honor, we call them the Galileans. They're visible on a dark night with only a modest pair of binoculars. Saturn is the second largest planet in the solar system and the sixth planet from the sun. And despite its immense size, its mean density is less than that of water, which essentially means that if you could find an ocean large enough to drop Saturn into, the planet would actually float. Clearly, Saturn is made up of very light stuff indeed. It can't be much more than a giant gas bag mixture of hydrogen and helium.